All right. Hello, everyone, and welcome to this session on machine learning for resource modeling. I'm Jesse Oldham, Group Product Manager for Mine Planning at Maptek. And joining me today is Steve Sullivan, Technical Lead for DomainMCF based in Adelaide. So last month we had a panel session on the whys of machine learning, and today we're going to dig a little bit deeper into the how. And specifically, we'll talk about how machine learning has been applied to over 100 different resource projects from around the world. And we found the results to be comparable with other methods, but that's accomplished in just a fraction of the time. In fact, some of the projects that had previously seemed out of reach of modern resource modeling methods have come to life within DomainMCF. I think it's safe to say that a proper resource model portrays the best understanding of geologic observations and facts available at the time. And as we gain more information about the deposit through drilling or other data collection methods, we want to incorporate that into the resource model as soon as possible. In this process, the resource isn't changing, it's our understanding of the resource that changes over time. And that increased understanding results in better decision making. So DomainMCF is not just about introducing a new technology to an existing process. It brings a totally new approach on how we turn raw data into something even more valuable. It brings an opportunity for resource geologists and their teams to bring new value to this strategic mine planning process. And in just a moment, we will show a pre-recorded webinar about DomainMCF. It runs for about 14 minutes, and after that, we'll host a live Q&A session. So you can, if you like, enter your questions or comments into the Q&A box, and you can do that at any time while the webcast is running, and we'll cover as many as we can. Also, as a note, we're recording today's session, and you'll receive a link to watch it over again or share with colleagues. So as I mentioned, we'll jump now to the recorded video, and then we'll jump into the Q&A session.
DomainMCF is our commercial name for the first release of our new generation domain and grade estimation processing engine. So you can see some of the key criteria there. It's very fast, robust, automated, easy to integrate into existing workflows. It is platform independent, and so it takes generic data and produces generic output so we can interact with any platform. It's been tested and proven on hundreds of data sets, and we're looking for our first commercial release later this year. So let's talk and more action. So I'll just change the screen over and have a look at live demonstration. So we're going to be using here a data set. It's the Lachine data set in Ireland. It's a publicly available data set. This mine was in operation for many years and has now been completely exhausted, so the data is available. You can see on the screen here we're using both Maptek. Sorry, we're in the Maptek workbench. We have the Vulkan application and the DomainMCF application, both working in that Maptek workbench that Jesse outlined earlier. I'm using Maptek account for licensing of both these applications, and I've got Maptek Extend enabled here. So, there's some of the components that we talked about through the introduction being used here in front of you. The scale of this project, there's a kilometre by kilometre, so you can see there's about half a dozen different lead zinc ore bodies distributed over 4 by 5, 3 to 4 kilometres squared. So just remove the grid there, just have a look at that. We'll just rotate here. We've got over 7,000 drill holes. These are both exploration holes, which are the long vertical holes you see on the screen. And then as you zoom in closer to the ore body, and the ore body here is in the red colours, you'll see a whole lot of underground production drilling. So there's quite a wealth of information. The full data set here is over 600,000 samples. The overburden material is about 150 to 250 metres thick, and the ore body itself ranges from 5 up to 30 metres thick. So our challenge here today is to be able to model this and model this quickly and efficiently. Previous work during mining, they used to be able to do the estimation for this, build a new model every 6 months, maybe 12 months to on their annual resource or 6 monthly resource update. Using traditional methods. So today, as time is short, I will just come in and do a subset of that, or one of these ore bodies. This will be this ore body in front of us, as shown in that the extents there in the blue cube. So we'll just pick this ore body here and build that for you. So in doing that, I'll just remove the full data set and just bring in the subset that I'll use, and I'll use a selection file just to select the data. And also in this case, I'm going to just use the exploration data, the data from the surface. It's a sparser data set. I'll leave the underground production data out. We can most certainly use that, but let's have a look at just the exploration data. Okay, so there it is there, intervals of interest in red. And just to put you in the picture again, let's have a look at a cross-section. Most of us geologists like and are familiar with looking at cross-sections. So we'll just drop in a cross-section down here. And you can see there the lithologies there, obviously from the surface. There's some very close spaced areas of drilling, some more sparsely spaced areas as well. And again, the red is the massive base metals. And so you can see as we go across, the deposit itself is divided into many different zones. It's not just a continuous thick slab. So there are quite a bit of complexity there. So it's not just a simple matter of joining the dots and you've got a model. There's a lot of anastomosing units there which have to be integrated into a single one. Okay, so how are we going to do that? We're going to use DomainMCF. As I said, it's operating in the Maptek workbench. I'm using an alpha internal release version. Here's the interface here, and what I can do is I can set up a new job and give that a name. So, and you can name these uniquely so that you identify it later on. Just call this one data. Only needs 3 components. The sample data, so we can introduce data here. I've just got a CSV input. So what we have, any data that you can provide in X, Y, Z. So I'll just bring that down there. X, Y, Z, some type of geological attribute, and also different grade attributes, which we can bring in from there. So this is just a preview of the file. There's about 100,000 records in this file, so we can go through and have a look at those. I'm not going to model everything, so I have got options here to ignore things. So I can ignore particular columns, that, and just ignore a whole lot. So I'll just model a couple of those. Once I'm happy with my selection, I can approve that. If I need to do that repeatedly, I can save that format. So that data has now been uploaded and it's given a tick of approval. If I need to edit that data afterwards, I can jump in there and go back to the same editing environment and make a different selection. The next thing we need to do is define the space that we're going to build that resource model. So I showed in Vulkan that blue cube that we're going to work in. If you're working in a Maptek product, you may have a block definition file. You can upload that straight away. If you don't have one, you can click this button here and you can go and input where your origin will be, where your extents are in each direction, and the dip, plunge, and bearing of that. Natively, we can build the domains, but we've also got capability for grade estimation. So you can just tick on which ones that you want to estimate for this particular process. And finally, we come down to a blocking size, a parent block size, and sub-blocking schemas. So I can go OK to that. Again, that gets the tick of approval. And finally, we've got the option here to do limiting surfaces. So most projects have its topography, so we can limit modelling above the topography, whether that's a natural topography or a mine topography, and also some type of base surface, because we've got a whole lot of drilling down there. We don't need to model to the bottom of the earth. We can go through and just limit that as well. So there are 3 components I need, all very generic, all easy to upload. Got a couple of validation stages here which I can use, and when I'm happy with everything, I just start the job and the job starts uploading. So the data is wrapped up, it's secured, and then sent off to the cloud processing for working. Now you can see there's another job in action there, so that one there is being queued. So I'll just jump back into Vulkan, and like all good chefs, let's have a look at one that we generated earlier. So I can pick up this. The outputs of the DomainMCF is a CSV file, or if you're using a Maptek product, it's a block model format, so you can just bring it straight into your applications that in your Maptek workbench. In this case, I'm using Vulkan, but that could also be brought into Evolution or Eureka or BlastLogic. So I'm just loading this. Now what I've done is I've made the color scheme of the block model the same as the color scheme of the drilling, so that if the modeling is perfect, you'll hardly see the drill holes because they'll be identical colors to the ore body. So as I zoom in here, you can see here our minimum block size here is 3 by 3 by 1, so quite a fine detail. There's only about 2 million blocks in this model, so it's quite a small model. I have built up to 280 million blocks without any problems, and that was using 2.5 million sample points. So yeah, DomainMCF loves large data. So the more data you've got, the better. So remember, in this case, we're just working with the drill hole data. We could have underground mapping data as well. In this case, if you're in an open cut scenario, no problems introducing surface mapping as well, so incorporating it at the same time. So as we look here at the drill hole, we've got our ore body, we've got some footwall lithologies, and you can see how it's modeled these within the block model. So there's no intermediate surfaces here. We're just going from drilling to block models. The reason we do that, blocks and models are the key. That's what everyone else has a value add down the track, whether it be in grade control production, whether it be in geotech engineering, whether it be mine planning or in mine scheduling. Everyone works on a block model. So we're just working from drills straight into the block model. Okay, so you can see the correlation, and as we just scan through in a section view, we can have a look at the way the modelling is being done. You'll see as we go in the middle here, our drilling here is to find a couple of different ore body zones, and you can see how that has been broken up quite nicely with the DomainMCF domain modelling. You also might notice if you're eagle-eyed, there's a little tiny thin intersection. Now this is too thin to match into our subblock schema. So if you did want to model this, you have to bring your subblock schema down to say 0.5 metre or 0.25 of a metre. And no problems in doing that, just a little bit longer processing time. This model itself processes in under 15 minutes from drilling to what you see now. And so maybe you might add a few more minutes, maybe half an hour, and you can get down to 0.25 metre in the Z value. So you can control that with your inputs into DomainMCF. So here we have 40 different lithologies, 40 different domains. We've uploaded the data and it's generated all that within 15 minutes. And as a geologist, this output is very geological. It looks quite meaningful to me. I can see here there's quite the bounding fault coming through here. We have not input anything about the fault apart from what the drilling information has provided. So you can see how it's just tapered off that thing based on the lack of information. And so we're getting quite a geological outcome. So there we are there, a drill hole with negative information and then ore body developing through there. Another way I like looking at these models is in plan view. So if we just change our view into a plan section, and there we are there, we're in plan. I'll just reduce the view, so we're just looking at a couple of meters up and down. So you can have a look at that. So you can see that nice fault that we're looking at before. It's very sharp and hard contact. And oops, I moved a bit too fast for you there, but let's just slow that down. You can see it's quite a complex ore body. We're thinking better lens deep, that's easy, but no, there's a lot of action. There's a lot of little minor faulting there, which is causing that. Now, if we just rotate this plan view around, and you'll notice that I've reduced it down to just 2 meters above and below the bench plan here. You can see the little drill hole sticks, which is the lithology and the drilling, versus the domains in 3D in the block model. And you can see there's a very good correlation from the ore body here to the footwall rocks, and then the overburden in the middle there is the folding. So as I turn this around, you can see a very good correlation. And we're not seeing rounded, smooth shapes. We're seeing very geological shapes and very geological contacts. So that's a very quick look at DomainMCF and the outputs of DomainMCF. So Just jump back to our presentation there. And just in a quick summary, DomainMCF is a real data-driven system. It's taking your data, it's requiring minimal geological input apart from what you've applied to the original data, and building an automated system so it's repeatable. So it doesn't matter who sets it up and runs it, it's got to be a repeatable outcome time and time again. So ideal to put in a automated framework, as Jesse was talking about, into the Maptek compute environment. It's very fast processing. We're talking about 100,000 records there, and we're doing that in less than 15 minutes. If I took the 600,000 and 50 lithologies, I'm building all those 50 domains in less than an hour. And that is very fast. And it allows the geologist to spend more time thinking, analysing the data, making modifications and tuning the data, rather than doing CAD and wireframing and controlling implicit models. It's very easy to integrate into mine production systems. As I say, it's either a generic CSV which can be uploaded into a block model, or it's a direct BMF straight into Maptek systems.
We do have a number of comments and questions that have come in, so I guess we can jump straight into those. So one of the first ones that came in, what are the similarities with implicit modeling?
Yeah, thanks, Jesse. Yeah, I've got questions in the chat box here. Got questions and question and answers, so it's going to be quite busy. So that's a good thing we've set some time aside for this. Implicit modeling, yes, implicit modeling has been around for, I guess, a good 15 years. It's been quite a common approach to geological modeling. Key differences are with the DomainMCF is speed. Implicit modeling can be quite a slow process, not just in the processing itself, which can take hours and days, but also in the preparation of data and the controlling of implicit model in the starting process. There's many controls. I think up to 50 different controls you can use for implicit modeling to try and constrain your data to control the mathematical models. So another important difference is in DomainMCF is that the data, adding new data has a local impact. Implicit modeling, you can add data and that can affect an area of the model that can be quite distant from that data. So I guess the DomainMCF is giving you more local control. And in the work that I've done over the last 18 months in Maptek over the last 3.5 years, the outputs of the DomainMCF are more geological than what the average implicit model has generated in the past for the same data. And I guess that's a fairly generic answer, but the best way to test is to use your data in DomainMCF, use it in implicit modeling, compare the results. And we've done that for many different deposits over that time.
Great, thanks, Steve. Let's see. Are the geodomains named by the database geology code?
Yes, they are. So in the CSV file that we showed in the video, they've all got some type of database code, and that is what's being used and flagged in the resultant block model in DomainMCF.
Excellent. We'll come back over to, we'll kind of bounce back and forth between the questions and the comments. Came into the meeting a bit late. Is the drill hole data just lithology, or is it also downhole geophysics, or both?
In this particular case, it's geology, but there's nothing saying that you couldn't use downhole geophysics. You might want to use alteration. You might want to use some other qualifiers as well. So in this particular case, we were just looking at the geology code. And that geology code could be made up of various components as well. You could make a composite code with some scripting and model that.
Great. How do you domain if you have geologic surface or solids already modeled for a particular geology?
I guess a couple of things you can do there. First of all, you can use DomainMCF as it is, and then compare the results with your prior shapes. Or if you want to use those prior shapes, you can use, for some development we're just doing at the moment, you can use an existing block model as input to DomainMCF. So not shown in the video, but coming soon. We'll be able to take an existing block model, which has been built with your surfaces, and use that as a start point. And then as you get more data, use DomainMCF to do incremental updates.
As you've kind of compared those different approaches, Steve, of just maybe using drill hole data versus block model and drill hole data together, what are some of the impacts or significant changes you've seen between the two approaches?
The impacts really, Jesse, are on geological interpretation. You know, the data set we've used here was quite heavily drilled, which is quite heavily constrained, which is good. Where we have exploration data sets, and I've had data sets as little as 20 holes given to me, which I put in DomainMCF, really there's not enough data to constrain things geologically there. That's where an approach by the geologists to put their own interpretation, whether that be through polygons, lines, 3D surfaces, means that if you have that as prior input, then DomainMCF is building the model that's in the geologist's head. But if you've got real data to constrain things, then I prefer using the real data than the geologist's interpretation. Let the computer come up with the interpretation, and then maybe, you know, tweak the interpretation in areas where it may need it on the periphery or on areas of poor data.
Excellent. And I guess this is related to what you just said. How can you modify the domains if you want to change them, overestimating grade shells, like using polylines and leapfrog?
If you want to modify the domains, you can put your polylines as input to the process. You know, I just use drill holes, but you can use polylines, and I've done that with surface mapping. There's no reason you couldn't use that for underground mapping as well. Have that as input and run the model again. As I say, in this case, the model runs in less than 15 minutes. So you put your polylines, it'll still take 15 minutes because, you know, it's only adding another, you know, 100,000, 200,000 or whatever data points. So our processing is not dependent. It's not X squared or exponential. It takes the data and just uses it. And then the main, I guess, time component, or the duration of a particular task, is based on the output size of the model. So if you want 1 meter by 1 meter by 1 meter blocks, then it's going to take longer than if you do 10 by 10 by 10. So that's a constraining influence. The number of data points is not, which is very different to implicit modeling.
Mm-hmm. Yep. Okay. Let's see, what kind of cross-validation approaches are possible with DomainMCF? Is it possible to separate data into train, test, k-folds scheme?
Yeah, the DomainMCF actually does all the cross-validation for you behind the scenes. So you don't have to worry about doing it separately. It does that as part of the process behind the scenes. Now, in terms of output of that, and I think that comes into maybe what the next question that I can see there from Brian Anderson, is that doing multiple runs of DomainMCF will allow you to build up an uncertainty model. So every model you run is slightly different, just like if you're doing simulation for grades, which a lot of people are, especially in gold deposits. You can get uncertainty very easily for your geological domains as well. And then you can put an estimate around that of uncertainty. You can get heat maps of uncertainty. And that's very good for looking at a deposit and working out where you need to drill to then go through and target those areas of uncertainty. Now, if you've got an area that's 95, 99% certain, why keep banging drill holes in it? Why don't you go and target those areas where there's uncertainty? And certainly DomainMCF can do that. And we presented a paper at a conference in Australia on the mine geology, which is referenced on the Maptek webpage, whereby we've done that and produced those heat maps.
Okay, we'll keep going through. Definitely getting some good comments and questions. Appreciate everyone's participation. How does it go with bedded stratigraphy?
Bedded stratigraphy comes down again to the amount of data you've got. Some deposits, I've done some bedded stratigraphy in metals. In fact, the example that was shown in the video is bedded stratigraphy with lead zinc. As you can see, that's quite well-spaced drilling, although it's much more complicated than coal. It works very well there. when you've got wide space drilling, I'm talking about 400 meter spaced drilling for coal, and you've got a 1 meter seam, you need to do a little bit of work, and we certainly got better tools inside Vulcan at the moment using our grid count tools if you've got that type of deposit. So, you know, DomainMCF is one of the toolkits within the Maptek portfolio. It doesn't do everything and doesn't take over the world. You know, that might come in future generations, but at this stage, you know, we can advise, and your local Maptek can advise what is the best tool within the Maptek suite to use for your deposit.
And I guess to kind of go along with what you just said there, there's a couple questions around, you know, integration with some of the various tools. Also some questions around cost and different ways to access the tool. As Steve said, there's various integration possibilities built in with the tool now of how you can use this with Vulcan, Eureka, some of our other tools seamlessly in the workflow with accessing block models and the like. It is a separate product from those tools, and that was built in such a way so that it can be accessed by people that aren't current Vulcan users or any of our other products. So there's a much more openness in terms of use of the system. I think Steve also mentioned some things around the inputs and outputs and how it's related to that as well. And then regarding cost, there's a couple questions that have come through on that. Something we'd love to discuss with you. We don't typically discuss those things in forums such as these. So please contact your local Maptek representative to discuss some more on options there for accessing and cost of the tool.
Yes, I guess, Jesse, just going back to DomainMCF, we showed it in the video as running it within the Maptek workbench, not within Vulcan, not within BlastLogic, not within Eureka. So it's a standalone product, so you don't have to have anything for the Maptek portfolio, and you can access DomainMCF. Also, it's our first, I guess, software as a service. Yes, there is a user interface, but mostly it's a software as a service offering, so with a pay-as-you-use option. So as Jesse said, each of the Maptek offices has got people who understand and can know and can help you out with this product.
Yep. Well, let's see. Does it need to use composited data? And if so, is that done inside or outside the system?
It can use whatever data you throw at it. So it's up to you as a geologist to make sure that the data you input into it is the data that you want and is representative of the deposit you're working with. Yes, standard to use compositing data. That compositing data is not done inside DomainMCF. At the moment, we're targeting DomainMCF as an engine to do the computation to speed up that. There are many tools, not just within Maptek systems, but third-party systems to do compositing. So the system at the moment is very open. It just requires a CSV. How you prepare that CSV is up to yourself. We obviously have a lot of guidelines on how to do that preparation, how to ensure that your data is clean going into the process. And we haven't touched on that at the moment, but that's a very important. In fact, I think one of the next questions down there, has the data been cleaned up to only show 40 geocodes? And the answer to that is yes. Having worked with over 100 different data sets over the last 18 months myself, there's a lot of data that has been generated over many years. A deposit I worked with here has been in operation for over 140 years. In that time, there's been many different geological interpretations. Different parts of the ore body have been mined. Different interpretations have been mined. The nomenclature, the naming of different rock units has changed over that time. So it needs to have a fairly thorough database administration process to go through that. Now, over the last couple of decades, most people have got a standard database interface, and I've got database administration. So you would treat that, or that should be a default action, and you should be able to take your data. In reality, I find, and many of the consultants and many people who I guess who are in project evaluation looking at data from data centers know that not all data is as clean as you'd like. And so there is a bit of process there to have a look at things. Things that you're looking for is codes that are similar but not identical. So, QZ versus QTZ for quartz. That's quite a common one. And, just to standardize those onto a single offering. What I do is I do not change the existing data. I make a new column in the database and then have my interpreted codes or my standardized or normalized codes in a separate table, so that I can always go back to the raw data and the raw observations and separate them from the fact from my interpretations. Also, you may have several codes that are, you might have, in this case, I had 100,000 that I was working with. I might have 2 instances of one code. So that's not going to have a noticeable impact on the deposit. I can either remove that from my interpreted code, or I can just let it happen, and the system itself will look at that and find that it's insignificant and will have no logical or tangible impact on the resulting model. Remembering that we are building a model that's going to fit into standardized blocks. We're not honouring every 0.1 metre interval that the geologist diligently logs. Ultimately, we're giving this model to mining engineers, and if it's an open cut, they're probably going to bulk it up to 15 by 15 by 15 or some larger block size and pit optimize. And so some of that detail is not required at the mining level. Geologically, yes, it should be observed, but not necessarily take through to a completed model.
Right. Let's see. Question on have there been proven reconciliation works with this type of model?
Okay, I've just got to find there's questions everywhere, which is really good feedback.
Yeah, over in the chat. This was in the chat in particular.
Proven that reconciliation works with this type of model. Yes, we have. We spent a lot of time working with different types of deposits, different type of model, and we looked at the volume reconciliations. We've looked at geological interpretations. We looked at uncertainty. I've done comparisons there, and we're in a position that this product is being released and is being made available, and the early access versions are available in the next weeks. Because we've done a lot of testing on that. So reconciliation, there's a couple of questions about grade, and I showed grade in that. Mm-hmm. We've still got some work to do to reconcile grades. We developed the technology for iron ore grades. We've got some very good correlation for iron ore deposits and Fe grades. Other precious metal and base metal grades, we're still working on that. This is obviously a very new technique, and it's very important for people reporting grades, especially to their statutory bodies throughout the world, to have grades that can be justified and amongst your peers to be correct. So at this stage, we're holding back the grade estimation side of DomainMCF. The capability is still there. We've just hidden that. So if you do get early access, you can use grades as input. And grades are very important in terms of looking at clusters, looking at domain classification. So they'll be used as an influencer, but we're not reporting those grades back at this stage until we can quantify those and prove to you and to the estimation community that they are as squeaky clean as your current system.
All right. Let's see. And there's a couple questions around the algorithms using DomainMCF and a white paper on any of this. DomainMCF, as was mentioned, uses machine learning behind the scenes, and that's a broad spectrum. Our actual implementation is a Maptek proprietary implementation of this. But I believe there's a little bit more information that we've posted to our website. Is that right, Steve?
Yeah, we certainly, if you go to maptek.com, you can type in DomainMCF, and I guess there's a couple of things. There was we held a why machine learning session, a webinar. Some of you may have attended, and that went for about an hour and a half. So we discussed the why of machine learning, and so that video should be available, and probably will be sent out to all the participants of this webinar, just as background, not just on domain estimation, but a whole range of different machine learning technologies throughout the mining chain, I guess, going from exploration, resource modeling through engineering, optimization, through to process plant and reconciliation. So, Maptek's working on a whole lot of different angles with machine learning, and DomainMCF is the first of the MCF, which is the Maptek Compute Framework applications, which will ultimately chain together so that you can take the resource model and automate geological input, automate that through to a whole range of mining processes. So that's the roadmap and the direction that we're working with. DomainMCF is the first, and watch this space over the next few months as other applications are released into that framework. And as to the actual algorithms themselves, Maptek spent 3.5 years, so there's a lot of proprietary IP in there. So that's not something that we're going to release at this stage, and it's not something that I have the knowledge of anyway to share with you.
Right. There's a question here around being able to get surfaces from the output model. As you mentioned, we output directly to a block model, as that's the primary, consumption downstream and other things. Or grabbing surfaces from the output model within Workbench and some of our other tools, I suppose, is a question there.
Yeah, it's the there's current tools in the Vulkan and also a Eureka product to extract surfaces from block models, so that can be done at the moment. So I guess the main reason for looking at surfaces is historical. People are used to using surfaces. I guess in summary, the last 40, 50 years of, or maybe 40 years of computing has really just emulated what people have done on paper prior to that. Done sections on paper, built up some 3D shapes, and so a lot of the earlier computing is just emulate what we've done on paper. DomainMCF is trying to change that, and change can be hard. I'm not saying people will adopt it straight away, but are there some things that we're doing that we don't really need? And ultimately, the block model is the key for all mining related activities. It's the resource model. It's the model the geotech engineers put their information in. It's the one that the engineers do their optimization. They do their design on. They do the reserve reporting, resource reporting. So the block model is the key. So we're working towards, with DomainMCF and some of the other tools we'll be releasing shortly, an automated or at least semi-automated process. And how do we take people out of the equation? Not because we don't want people, but we're finding here in a lot of jurisdictions, there's a lot less people coming through the education system. Mining is no longer trendy. It's no longer seen to be the right thing. And we're finding that we have to, with our customers, improve processes so that they can still do their job. They've got less people to do that with, and semi-automated process is one of the ways of doing that. And in doing that, do we need to use surfaces? Possibly not. Yes, historically, yes, we do. So there are tools to extract that so that you can have a look at those. But not in DomainMCF. It's the compute engine, not the visualizing engine. So you will need a visualizing engine. And again, within the Maptek product suite, there's several, and obviously it's an open system, DomainMCF. So if you're using other third-party products, you can take your data from CSV and do whatever you need to do in those tools.
Andrew asks, mining used to be trendy? So hopefully.
Well, I've locked my career into it, and you have too, Jesse. And so most people on this webinar, which is good.
Into mining before it was cool. All right, let's see. DomainMCF will work with narrow vein gold deposits. Could you use grade and logging to create the domains?
I guess the short answer is yes.
Yep.
We have worked with narrow vein gold deposits. Again, it comes down to the sample size that you're using in that, and the continuity between the veins, and whether you're using just drill holes or whether you use underground mapping, etc. So yes, it has been used for underground gold. And one of the deposits, I can't mention the name, but one of the deposits I worked on this year is very highly faulted, and without adding specific faults without controlling and having input, DomainMCF was able to show structural dislocations that would have taken the geologist days or weeks to do it manually interpret, but it was showing those dislocations just from the relationship between adjacent data. So that's quite impressive, and wasn't really one of our design criteria. We hadn't thought of that, and we hadn't, and customers we worked with in the early days hadn't said, hey, we want to use this to find out where our faults and structural changes are, but it's kind of a very beneficial side effect. And I think we wrote about that in Forge earlier this year.
Yeah, and a related question is asking about integrating structural and fault information into that. And that was one of the impressive things that we've seen over a number of different data sets, is the way that that's reflected just from the data without additional surfaces or data inputs. It's grabbing that from the drill holes. Is that right?
That's right. I mean, you can, if you've got structural surfaces, yes, that's mapped data. Then we want to use that as well and use that as input. But if you don't have that, or if you just want to run a model with the data, the drill data and your mapping, and then have a look at it and then compare with your mapping, and we've had a couple of cases of that where people have given me the geological drill hole data, and I've modeled it, and then we've gone and had a look at their surfaces that they've interpreted, and there's been some very interesting comparisons. Some have been exactly spot on, and some have raised a few question marks. And I had one customer who actually thought, wow, we didn't think to look there, or we didn't think to do that. So the computer, the AI, actually had a different interpretation than they had. And I know you and I, Jesse, we joke about having 4 geologists and 6 different answers, and the computer came up with the 7th, which gave them some I guess another example, another thing to analyze and think about. And we're not looking at DomainMCF taking away the geology. We're looking at DomainMCF taking away some of the, shall we say, not so interesting work, maybe the database work, the CAD work, the drawing on the screen and those type of things. Let's get models quickly. And we're talking 10, 15 minutes for this data. I've done some data up to 1 hour, 2 hours, but that fast iteration means that you get to spend more time looking at the data, thinking about the data, and saying, okay, I'm not sure there, let's put a drill hole, let's make certain, because I can make an interpretation, you can make an interpretation, all your geologists can make a different interpretation, but really all you're looking at doing is justifying to your manager why you're spending money drilling that hole. And if you can say, well, there's uncertainty there, that's why I want to drill that hole, so that when we put that stope shape or we put that grade control boundary around that, we are making the best decision at that time. And for that small outlier, we remove that uncertainty and we get better production or better profitability through the mill.
Yep. And with that, added insight, and couple that with the run times that we're seeing, you're able to, like you said, spend that time more on interpretation and really digging into the data rather than manipulating points and lines and triangulations and whatnot. You mentioned uncertainty there. There was a question around maybe a little bit more about the uncertainty application. Is the process manually run multiple times? Can be scheduled to run so many outputs?
You can manually run that, but we have scheduled it so you can just tick a box and say you want to run it 10 times, and it runs 10 times. So that's the easy way to do that. Yeah. Mm-hmm. I'll pick up the next one about structural information. Can the MCF capture local variation and anisotropy and then implement this into the model? A couple of ways of doing that, I guess. Within Vulkan, there is local, you can build anisotropy models, and you can put vectors into each block of the model. And that, again, as I said before, can be introduced at the start of the process. But we've also found that the techniques behind DomainMCF are looking at the data relations between different data points and it's building and doing a very good job of that local variation and anisotropy itself. So it's embedded into the process. So I've had some very folded deposits and managed to map the domains very nicely without having any user control, without any local anisotropy control external to just the native process. Now, unfortunately, of the 100 plus data sets I've used, all of them, bar the one I've shown today, is proprietary and under non-disclosure. So I guess the best way to see that for yourself, if you've got a complexly folded deposit, is to have a look, just contact your local Maptek office and use the product. As I say, yep. It is available on hourly rates, so you're not going to break the bank just running it for a couple of hours. There's been some very nice deposits. It pains me to sit here and not be able to share them with you, but almost a mylanitic zone, so heavily folded and deposit with 800,000 type data points, and just came up with a beautiful geological interpretation. So showed that internally with some of our geologists, and they were quite amazed at what was got from the data in less than an hour. So the proof, I guess, is using it and trying it on your deposit.
Mm-hmm. Couple question here around is the machine learning algorithm trained on a range of real world deposits and commodities?
The machine learning engine we're using, it looks at your data for your project independent of everyone else around the world. So it's not at this stage aimed to come up with using all the deposits in the world. At the moment, it just looks at your data and looks at the relationships of your data, your geology, your assay information you put in, and produces the results based on that. So we're not trying to tune it in at this stage. I mean, there has been a suggestion that we have a tick box on the interface saying I'm working on a porphyry copper, so tick porphyry copper, and it goes through and looks at porphyry copper characteristics. If you're working with a narrow vein gold, tick that box and away you go. So that has been a suggestion. That's not currently in the product. Maybe it is in a future state, but we don't have access to all the deposits in the world to learn on. Each of the deposits out there is generally owned by a company, and that's proprietary information. And we certainly need their permission to use it in that sense, and we haven't sought that. So it takes your data and looks at it and builds a model from your data.
Has DomainMCF been used, for example, in grade control to build a model, remove the grade control, and then compare the results with the exploration data only?
Yeah, that's an interesting one. I have got the data set that I showed from Lachine with the lead zinc. I built that with an exploration data only. I've built that with the exploration plus the underground grade control data, and I've done comparisons with those. And I'll be putting together a paper on those comparisons and putting them out in September Forge. So subscribe to Maptek Forge. I don't have those results yet because that's still a work in progress. But yes, that process has been done, and it's just a matter of wrapping that up and reporting that. So yeah, good question and very relevant to customers out there.
You touched on this earlier. I think Chris wants to dig into that maybe a little bit more. How do you get different geology models with the same data?
You get different geology models with the same data because of the process we're using. Much like you do with simulation with grades, they run an initial slightly different seed point and a little start point. And by doing that, you can get different outcomes. Just like if I was to give the data to you, Jesse, and say, Jesse, you interpret this geology, you come up with an answer. I do my own interpretation. We give that to our boss, and he'd do a different interpretation, give it to someone else, and they'll get, so say 4 geologists, 6 different interpretations. So DomainMCF, it emulates the human nature there in terms of it can generate different models. The beauty about that, and some people might be a bit scared about that, but if you've invested weeks and months interpreting your model and got a single model, you're not likely to go and make an alternative model. It takes another 6 or 7 weeks or whatever it might take. The computer can make those different models within minutes, and so you can then do a comparison and then do an uncertainty analysis on those different models. And when I say different, I don't mean wildly different. They're just subtle differences, and it's all in the boundary effects. And again, I guess the proof is in the using. And again, that will be in the September Forge on writing the paper about uncertainty modeling for geology and the differences. So look out for that one.
Let's see. This is a real good one around kind of some of the data you want to feed DomainMCF. Any rule of thumb for trying this tool in a project, such as minimum number of samples, drill hole spacing, any of those things that might affect what you're getting on the other side.
Very generic, I guess. Very hard to answer that. I guess minimum number of samples. I did have a customer, as I said before, came to me and said, "Hey, look, I've got 20 drill holes. What can you do for me?" And I said, the best thing you can do is get a drill rig and get some more drilling, politely. But yes, we can build a model for 20 holes, and it gets, it's very fuzzy, just as like you would do with your pencil and paper or your computer CAD. You get a very fuzzy model. The idea is really the best advantage of DomainMCF is those very complex deposits, those ones with lots of data, the ones that are going to take you weeks or months to try and do an interpretation. Get those, have a look at, get an answer within a few, within an hour or two. Ideal for people doing project evaluations in mergers and acquisition teams. They're going to data rooms. They've got, customer that we have may or may not be on the call. He's worked with a team, a finance team. They have geologists, engineers, accountants, and legals. They have 2 days once they get data from the data room to give the board management a recommendation whether to invest or not. 2 days. So if you're asked to do a proper geological model and an engineering study and environment and all those legal in 2 days, just not possible. DomainMCF means the geologist can get a model out very quickly, pass that to the engineer. They can do a very quick assessment. You can get within your investment criteria and your NPV tolerances very quickly. So, that's the type of thing it's really, really good for. Minimum number of samples, I mean, I'd say the more data you've got, the better. Drill hole spacing recommendations, really that's whatever data you've got. Spacing is not so much important as in the variability of the deposit. So use what you've got. And as I say, if you use it for 20 minutes, it comes up with an answer you're not happy with, well, you've only invested 20 minutes, move on, go back to your traditional technique.
So we've got time for just a few more here. Let's see, I'll grab one from the question and answer and then back to the chat. Does it produce a regular model or can it produce a heart model as well?
It can produce a regular model. It can produce a subblock model. It can't currently produce a heart model, which is a special Maptek model for which we use in the coal area. Not at the moment, so that doesn't mean it won't in the future, but at the moment it just does the regular or subblock models.
Will DomainMCF eventually be able to be added to the workflow manager to automate the process of interpretation validation even further? Yes, so that's something that we're looking at even for, hopefully in the near term, of adding that to the workflow manager for exactly the reasons you said there, to help automate the process. As you get new drilling in, you'll be able to automate some of these things.
In fact, Jesse, that development was started last week, should be out in 2 weeks' time. So that's happening.
Excellent. Would Maptek be interested in trialing this with a structurally complex coal deposit? Have you done any of those thus far, Steve?
Yeah, I do a fair bit of work in India and China, and we've got the Australian continent pushing up into Asia, and all the coal deposits are quite complex. And it would be interested. I mean, yes, we are interested in looking at that, but now that the product is available in early access, you can access it and do it yourself. But we'd be happy to advise you through that process.
Let's see, can you get strike and dip into each block during this process?
I have to think about that. I would say Possibly. I haven't tried that myself, but I know there's tools inside Vulkan. There may not be tools inside the DomainMCF, but inside Vulkan to do that. So I guess we'll just maybe get back to everyone with that answer. Not something I've got off the top of my head there.
Okay. All right. So I think that's pretty good. We're pretty close to time here. I did want to thank everybody for attending. Hope you enjoyed the webinar.
So I guess we'll go for this first question I can see here is, can you generate alternative geological interpretations to get an estimate of the uncertainty in geology?
Yes, Gary, the DomainMCF model that you saw on the screen in the video took about 15 minutes to generate. The process itself works a bit like simulation in terms of as a random seed. So every time you run it, you get a slightly different interpretation of the geology. So we have a concept where you can tick a box and run an ensemble or a suite of runs, multiple runs. And you might do 5 of these, 10 of these, and then you can use those differences between those 10 runs to look at what parts of the model are uncertain. You can get a quantification of that uncertainty. And just as if I gave a data set to you, Gary, you then did some interpretation. I had the same data set. I gave interpretation. You give it to a third party, they'd have a slightly different one. We can use that uncertainty to start targeting areas where we need extra drilling. There's no point in plugging away holes where we've got 100% confidence or 95% confidence. Where there's disparities between the different models, we say that's an area that we need to reduce our uncertainty, and it's good targeting. So that is an automated process. And it comes about just like you have with simulation for grades. You're running multiple simulations and you're getting a different outcome. This does similar, but here we're talking about domain and domain boundaries. And it's largely an overlooked thing in resource modeling, because to build one set of domains can take you days, weeks or months. So to turn around and then do a slightly alternate set, you haven't got that time in a production sphere or even in a resource sphere to do that. So now having the ability to automate these tasks makes it a lot more easy to introduce that geological uncertainty into modeling, and then also take that through the whole design and evaluation process.
Perfect. So we've had a few questions on how much control we have over the modeling and whether we can use things like CAD data or triangulations. Several people have asked this question, so I think that's a good one for you to answer, Steve.
Okay, in general, you saw in the interface there, and I might just stop sharing the screen here just for the moment so you can have a look at us. The input data is a point located data and some attributes, so geology code and some variables. So that data in my instance here came from drill hole data. That can be raw data or can be composited data, whatever you normally do with your data. Generally, compositing data is composited. Now, all that pre-processing is done outside DomainMCF. DomainMCF is your compute engine. You can do that pre-processing in a Maptek product or a third-party product if you're more familiar. And the DomainMCF product has been made open so that you can input CSV and get CSV out so you can use any product. So if you've got mapping data, you've got polygons in section, you can use those as long as you've got X, Y, Z and some attributes, as well as drill data, sample data, underground channel data as input data to the process. So you have that control. I generally, the model you've seen was completely just drill hole based. Initially, I ran it just with exploration data, those vertical holes. Later on, I introduced the underground data just to see the difference between that. And it did make a difference, of course, because the tighter you've got of the data spacing, the more control you've got on the results. So yeah, it's quite flexible in that regard.
And just to clarify for one of the questions from one of our guests, that drill hole data, you've composited it before it was uploaded to the cloud for processing.
That's right. Yeah, I composited. I did that outside of DomainMCF. DomainMCF is not designed to do that pre-processing. We've got so many other tools just in the Maptek product suite that can do that. So it's purely it's a cloud service. I think there's a question about that. It's something whereby the data is input, it's secured, compressed, sent up to the cloud with the processes that are required, run on the cloud, hence the speed of the data, because we can dial up a very big compute, and then we can download securely the data on the as output and work from there. So yeah. It's purely the engine, and in the MCF means Maptek Compute Framework. So DomainMCF is really the first of a series of products that will be released in coming months, which allow you to take various components of the mine operation process and link those together and automate the process, so that you've got a full audit trail from data through to MPV.
And sticking with the theme of data, a few questions have come up about features that might cut through the deposit, dikes or faults. I guess this is a really interesting one to look at, given some of the extra information DomainMCF has been able to establish from data when you've put that data through the process of DomainMCF. Particularly with respect to faults.
Yes, I guess when we started this process 3.5 years ago, we were looking at a particular deposit type. It was a kind of strata-bound iron ore deposit, and it didn't have complications such as dikes, and that had its own subtleties. And as we've gone over the last 18 months across a whole spectrum of different deposit types, probably in the order of well over 100 that I've modelled, looking at laterite nickel, looking at porphyry coppers, IOCG deposits, bauxites, narrow vein gold, a whole range of different things. Some of these things, such as dikes and faults, have come out. They're in the data. If you've coded your dikes, your dolerites, or whatever you've got with a particular code that's consistent, and then we've found that those structures, even as narrow as a metre, depending on your block size, are coming out as linear structures. Faults themselves, and I wrote an article in Forge earlier this year, the Maptek Forge, faulting is coming out very nicely without user control, just looking at the relationships between different samples, different input data, and looking to see whether it correlates or not. We're getting some very sharp faults which have been interpreted automatically by the AI machine. So it's quite nice. Now, I have got lots of examples of that. Unfortunately, apart from the data set I've just shared with you in the video, they're all proprietary and we're working under non-disclosure. But there are some lovely examples, and I guess the best example, if customers have got data, is to try the service. So this is now available in early access with a final release or the first release expected in about a month or so's time.
Perfect. That sort of feeds in nicely to the next question, which has come up. Some people quite excited by what they've seen here, and they're curious to know how long has Maptek been developing this technology, and when is it going to be available? So you pretty much just answered when it's available, but maybe a little bit of background.
Yeah,
on
so
how
yes,
much
we started this was 3.5 years ago. So it was an early adopter customer in an R&D program, and we really started publicising it with some presentation of papers at conferences over the last 6 to 9 months. And I know I presented at about 4 or 5 conferences, and we presented at a couple of conferences in the US earlier this year. And I know, Gary, you're submitting a conference over there in Europe. So we've only just been publicising over the last few months, talking to existing customers, doing demonstrations, sharing data. And we're really excited ourselves to be able to now launch this product and let people use it and get the benefits of that. And from my perspective, with a lot of experience, the major benefit is speed. We can turn around models very quickly, and that enables the geologist to spend more time analysing the model, thinking about the model, maybe modifying some input data, and doing more geological thinking rather than doing CAD work or trying to work out how to join wireframes or control implicit models. So it has speed is I guess an enabler for better geological interpretation and models.
And a few questions have come in looking at various types of deposits, potash, gold, where the structure is very heavily folded. What do you think about that kind of deposit? And have we had any cases of looking at that in the testing so far?
Yeah, I've had a case late last year, which was I guess it was a slate belt gold deposit with structural control and a beautiful fold in that, plunging antiform. And that mapped beautifully, just with DomainMCF, no controls, no use of LVA or vectors to control it. Also, another example earlier, a couple of months ago, where we had a deposit that's been mined for 40, 50 years. I've never really come up with an acceptable geological model, and we were able to, it was a high strain myelinite zone, which was a very acute folding, and that came out really nicely as well. So it does that, again, just looking at the relationships of data without necessarily needing lots of user control. And I know, Gary, yourself in Europe, you've got a customer there who's got a quite highly folded deposit, and from memory, they use tens of thousands of control points, don't they, to try and map it around. So, with DomainMCF, we remove that onerous task.
Mm-hmm. And some questions here talking about asking about the preparation of data, whether the drill holes have to be completely logged, every hole completely logged with every domain you want to model. I think this is maybe a good opportunity just to talk about the importance of preparing the data well for DomainMCF and what's involved in that.
Yeah, Gary, this is a key question, and it was well picked up by who asked it, because data preparation is the most important thing. I guess a lot of deposits, and I've got a customer here who's been mining continuously for 140 years. There's a lot of generations of geologists there. There's a lot of different rock types. Those same rocks have been called different things over those generations. But the same rocks have changed as they've gone down dip or down plunge to different metamorphic grades or different alteration types. And so it's very important to have a normalized or standardized data. Now, when I go through data sets, I'm very careful as to separate fact from interpretation. So I'll take a data set and I'll make a new column in the database, and that's where I put my interpretations or my standardizations. Simple things like, if you've got a quartz vein, it could be called Q or QZ or QTZ. It's standardizing that to one. Just pick one and use that as the standard. Things like using uppercase, lowercase, those type of things. Some of these systems can be case sensitive, so just standardize on something. Missing data is another important thing. A lot of systems use a negative or flag for numeric data. You have to be careful if you're doing numeric data, what you use as a replacement. And there's tools when you do your compositing, certainly in the Maptek product suite, to control that input, so that you don't have to do any manual manipulation at all. So that data validation is key. Anecdotally, at one deposit I had, there was over 250 geology codes, and I put it in DomainMCF, came back, which looked like a modern abstract art painting, and showed that to the geologists, and they said, did we give you that version of the database? Sorry. And then they gave me one that had 25 codes, standardized, normalized, and it came out and it looked geological. So data preparation is key. And I've heard and discussed with other practitioners or in the research field with machine learning, not just in geology, but also in mine planning and in the process plant and metallurgy. You can spend between 70 and 90% of your time getting the data right, and then the last 10 to 30% is using machine learning and doing the analysis. So data preparation is key. Get it right, and once you've got that standard, stick to it.
And when we've looked at this project in this video and a lot of the projects that we've studied, we're looking at really exploration data, modeling a block model for a deposit. But some people are asking, other applications, can they use it perhaps just to look at the next bench or the next blast and model that? I feel that one of the great opportunities, having used DomainMCF a little bit, is how fast it is and how quickly you can look at various different parameters and produce different variations of the model. What are your thoughts on that?
Yeah, there's several different reasons for using DomainMCF. One, yes, is in resource geology, evaluating. You might be working in a corporate office. You're looking at potential acquisitions, and you've got across your desk, a deposit or two deposits every week as you're scouting around the world. Your team scouts around, and you may only have a day or two to evaluate that deposit. But that includes yourself, the geologist, the mining team, the legal team, the environment team. So to do that traditionally is just not practical. So DomainMCF allows you that fast turnaround, even if you only get within 90% of what the model should be. You can get that fast. You can get that in 10 minutes, half an hour, and you can start making assessments and making value judgments, and seeing that that's within your investment criteria. So that's one application. Another application is just your general resource, mine resource updates, and just on a resource basis. Another application is grade control. As you mentioned there, you can use this very fast in grade control. We had some data we were working with a couple of months ago, and we were doing grade control updates in 2 minutes. So we're taking all the new blast hole data and doing the domains and the grades in 2 minutes. So it was a very, very fast turnaround. So you can get that out, get your dig polygons out to the machinery, and there's no delay in that time. So really, what we're talking about is removing the geologists, whether they be grade control, resource or corporate, from being a bottleneck in that evaluation process, and getting to turn around things faster and then push that out to the end user. The other application that I've found, and that's just through experience, is DomainMCF. We just talked about data validation. It is a really good data validation tool itself. Now, numerical data validation can be done in databases and spreadsheets and all that, but the visual validation that DomainMCF has given me with a lot of deposits is really good. You can model a deposit, 15 minutes, you've got the result. You have a look at a few sections and plans, and you can see, your eye picks up, that doesn't look right, what's going on there? And I had an example recently where there was a code that had been used 30 years ago that was no longer relevant, and there was still some of that in the data set. And so it just showed out very easily as an anomaly. And so change that, run it again, and you've got an up-to-date model. So yeah, multiple uses there, Gary.
And quite a few people are asking us about grades. So how is grade estimated? What does grade do? So this would be a good opportunity to explain what we actually do with grade data and what we might be doing with grade data in the future, and how DomainMCF would fit with the overall mine planning or resource modeling process in Vulcan, and within Maptek, and also a little bit of an understanding about what kind of data density we feel we need in being able to get suitable results. So the density of drill holes, for example, or drill hole spacing for a project.
Okay, Gary, that question's got a lot of tentacles on it, so I'll address little bits of it and remind me if I'm missing any. Grade, grade is very important. It's a critical thing for all our projects, and the grade estimation itself has been around for at least half a century, maybe a century, and in various different guises. And DomainMCF overnight is not going to change the world with grade, and that's not our objective. Our objective is as a fully automated, auditable process. Now, we started this research project with iron ore, and we have tuned the estimation of iron ore grades through that process, through our research and development. And so, we're quite confident that we're getting very good correlation with iron ore grades and original samples versus the outputs. Now, iron ore grades are often between, depending on where you are in the world, 20% in some Asian countries, up to 65% in some African countries and in Brazil. So, there's a very different set of numbers there compared to base metals, which are in the range of as 0.5 to say 10%, or when you go to the precious metals where you're talking down to the ppm. So the precious metals and base metals, we've still got some research and development. So you'll see in the early access version and also the first release, we won't be declaring grades for those elements, but that's a work in progress, and we'll release that when we have that ready. And to do that, we're not taking that lighthearted, because there's a lot of true and tried methods, and to introduce a new one, we need to prove to the industry and to practitioners and to the statutory bodies around the world for reserve and resource reporting that this new technique is acceptable. So now, in saying that, grades are important in terms of the domain classification and the domain generation. We use that in terms of a cluster analysis, looking at the combination and the relationships between, say, lead, zinc, and copper, silver, and how they relate to the geology code. So in that instance, the grades as input are very important, because they can control your boundary conditions. Now, with respect to some of the other things there, you might have to remind me, there was a couple of other questions on there.
The question's really around the density of data that's required in order to get a good result, which I think you could say is really dependent on the deposit itself. It's not a simple one-size-fits-all answer.
No, that's correct. You've got a coal deposit here in Australia, and it might be drilled at 400 centres, and that's measured. That's right to go. You might be doing a narrow vein gold, and you're drilling at 10 metre centres. So it really, as you say, is dependent on deposit type. DomainMCF works best with a lot of data. I've had a customer give me 20 drill holes, and so I could use it for 20 drill holes. Took about 2 minutes, came up with a very broad brush example. Now I could run it several times, come up with other alternates, but there's not really enough data to control it, and it's not designed to deal with that. There's so much interpretation that's the geologist, or there's so much space of which any person or algorithm could work. So large data sets, and the ones that worked best are the ones that, we're working with 500,000 up to 2.5 million samples, where physically to do that manually is nearly impossible. To do that with some other automated techniques just takes too long in the processing power. So the duration of compute for DomainMCF is not based on the number of samples, it's based on the output model size. So if your output model is 100 by 100 centres, it's almost instantaneous. 10 by 10, it's a little bit slower. And if you want to go down to 1 metre by 1 metre, then it'll take a bit longer. So that's more the constraining effect, not the input to sample data. So add as much data as you've got, make sure it's factual, leave the interpretation out, let it make its own interpretation. Compare that with your previous models and your previous interpretations. And in some cases, we found some quite nice surprises. Some areas in one particular area between two deposits, and we had some sparse drilling, and DomainMCF was able to point an area that was right for exploration targeting. So that was quite a nice surprise for one of our local customers a couple of months ago.
And to extend a little bit on the processes that are going on in the background to generate these results, there's a few questions coming up about, is this just implicit modeling in the background, or a signed distance function, or is it kriging? What's going on? So this is really a whole new proprietary machine learning software technology that Maptek's developed.
It's completely new. It's not using any of the technologies that you just mentioned, Gary, and it's a proprietary technique that Maptek, has said, we've spent a lot of time investing over the last 3.5 years. So at this stage, what I recommend to people is, have some input data, use it, look at the output data, compare the inputs and the outputs, and if you're happy with that, then, and if it's better than your current technique, then that's something you should be considering for your processes. The actual detail of that, we have got a summary paper that was published in the conference last year, and that's available on the maptek.com webpage under DomainMCF. So if you want any more information, have a look at that.
There's quite a few questions coming up with people asking various things, how would I learn this, or I'm not familiar with this type of technique and I want to learn how to do it so that I could apply it in my mine, or do I have a license for it and how can I get a license for it? For those people, all of those questions will certainly be easily answered by your local office. Please get in touch. We certainly will be able to offer training and licensing and things like that when the time's available. So there's no problem there. Like I said, please get in touch with your local office regarding those questions. Just have another quick look if I can see some other.
Yeah, I've got one here. It says, how about smearing of grades across domain boundaries? When you do estimate grades, they are within the domains. So that's if you've got a grade within a particular domain, it stays within that domain. So as you would if you were doing hard boundaries in conventional grade estimation. I've got here, do you think it appropriate for a deposit with high variability or complicated structural control? Yes, it is. In fact, some of those deposits which are highly variable and complicated work the best because it just takes you too long to do it manually. If you've got a lot of close spaced data, it does, as I mentioned before, the fault modelling for you, and we've seen some good results out of that. Another one here, can you do rotated models? Yes, we can. You can look, if you have a look back through the video, which we'll send to you, link to next week, you'll see in the panel there that you can have inclined and rotated in around Z, but also inclined in X and Y, so dipping and plunging models as well. So the standard functionality with the Maptek product suite.
And with respect to people who have asked questions about whether they could use their blast hole data or their underground drilling data, really, so long as we can composite that data, we can put it into DomainMCF.
Well, you don't even have to have composited data. It's just any XYZ data. It's whatever you require to be used. So, whatever your current process is.
Yeah, but certainly those, sorry.
No, sorry, keep going.
I was just going to say, but certainly for those people who are asking about their underground drilling data, that can all be applied, can all be used by DomainMCF.
That's right, yes, yeah. And it was in that example that I showed on the video. Another question, have we worked on coal deposits? Yes, we have. And there's a South African coal deposit we looked at recently where they were not so much interested in the coal, but they were interested in the dikes and the sills going through that coal. And we were able to use DomainMCF to evaluate those and join those up. So that was another example. There are a lot of tools in the Maptek product suite which handle coal. We've got some very good grid calc and fixed DHG tools anyway. So sometimes it's better to use those tools, and DomainMCF is just one of the toolkits in the Maptek and a workbench that you can use. So it's really a matter of picking the best tool for the job, and certainly your local Maptek office can help you from that.
And for those who are getting contact angles from the drill core, is there any way they can apply that information in DomainMCF?
That has been raised a couple of times, and we've got that as a development project at the moment to use those as vectors to do local control. So that hasn't been developed yet. It's sitting there as a project, but there is, again, it's factual information, and I guess the only question there is how far the influence should be on that, and whether that's just a local thing that goes for 1 metre or 10 metres or 100 metres. So we need some type of way for the user to input that we want to I guess, bias that data in that particular orientation.
And previously we've had people asking questions about how DomainMCF could be incorporated into other products and processes, perhaps into workflows or things like that within the Maptek ecosystem. Can you tell us a little bit about that?
The Maptek workflows, which came out last year, the DomainMCF is currently being updated. So by the time we got released, we will have the ability to tap that into a workflow so that you can have your database updating, that feeding into DomainMCF, and then output from that through block model, which can then trigger other activities such as a pit optimization, stope optimization, or any other process that you want to run off your block model, reserve reports and volumes and tons. So that'll be available by the release in next month. And it's all a part of, as we mentioned before, that automated process whereby we're automating the data. So we come up with a data-driven process whereby you change the data and the process ahead of that automatically ripples through and provides the update and to whatever you want, whether that be web-based reporting, emails, stuff happening. It can trigger different events.
And so once a geologist has used DomainMCF and they get their results, what can they do about editing that or manipulating that to maybe further influence the results going forward if they want to add a little bit of their own flair to it?
I guess DomainMCF is a compute engine, so it doesn't have any graphics itself. So you'll need other software, and Vulkan or Eureka in the Maptek suite, or your preferred if you're using a third-party product. You can use tools in that to help post-process the model in terms of domain classification or anything else you want to do. You may want to add some more input data and rerun the model. And as I said before several times, it's very fast to do that. So, you've got those tools outside DomainMCF to post-process, or you can rerun it with some new data.
And once we generate the results, how do we go about validating that data? And can you tell a little bit about how we've validated it compared to, or validated results from DomainMCF compared to other or more conventional techniques?
Yeah, I guess once you've got a block model, you can use any of the conventional techniques that you would use then for validation. So if you're talking grades, you can use your swath plots and look at sample data versus model data. If you're looking at domains, you can look at volumes. You can compare that against your wireframes. If you're using wireframes, you can compare that against block volumes. And that's been an interesting exercise. I've often gone into a mine site. They've given me the data prior, I've modelled it up, come onto the site, do the demonstration, then they say, okay, here's the surface that we used prior. I then load them up live and we have a look and compare those. And that's been a very interesting exercise. Some we've had exact matches, some we've had some variation, and it's those points of variation which have caused some interesting discussions. And in some cases, led to people saying, hey, look, well, maybe we need to revisit some of those areas. We've got a different interpretation, and there's some value in using, shall we say, a third-party way of looking at the data. So, so validation, what we're doing is just computing something differently. The tools for validation, the tools for either data validation upfront or model validation are just your standard tools.
And when you've been working on some of these projects and you're doing some test runs and then maybe some runs with the customer, do we see the results are exactly the same? And if not, why not?
We never see the results exactly the same. That's for sure. Using a different technique, there's always differences. I mean, I can't really go into specifics. It's because each model is different, but there are differences, and differences are good. They open a geological discussion, and as we've mentioned several times, if there's 4 geologists in the room, you've probably got 6 different geological opinions. So it's just a different geological opinion, and it needs to be looked at and discussed with vigor. And just because the computers generate it doesn't mean it's right. So. And that's a trap for, I guess, any semi-automated or automated system, is that the data going in doesn't necessarily mean the data coming out is representative. You need to make sure the data validation, as we discussed earlier, is the key component. Get the data right as best you can, and then interpret the model. But where there are differences between the existing conventional process and this process, there's an area for, as we said before, justification of why you should spend your drilling dollar. Instead of just filling in at random at 25 by 25 metre spacing, here's a technique to justify why we need to put 3 holes at 10 metre spacing in this area and only 1 hole at 50 metre spacing over there. You can actually quantify that and qualify that to the people you have to justify your drilling expenditure.
And so you're just speaking about data and preparation. Do you have to do any normalization of the data before it's applied? So perhaps smoothing out outlying data or something like that?
I guess some data you get, normalization or standardization I'm taking is just looking at the codes and making sure the codes are consistent. You will always, in some data, have a very enthusiastic geologist, and I used to be one of those many years ago, who would log things slightly differently and very detailed. And you might only have 3 instances out of 100,000 of one rock type. Now, that's probably not going to have much impact on the deposit. It's probably not going to have much impact when you consider that if you've got 3 intervals at 0.5 metre width and the engineer's going to bulk your model up or regularise it to 15 by 15 by 15 metres for their open cut shovel to dig it, it's probably not going to be key to have all of those very minute data. So I always preserve that data, as I said before, make a new column, an interpretive column, and then just focus on the key 20, 30 or 40 rock types and lithologies. And some of those minor ones, if they're not important, I just let them slide. Because we are looking here at a model that we're going to dig. We're not looking here for a PhD on a particular very detailed aspect. So it has to be a practical and pragmatic model that you use and generate.
Okay.
Now, I've got a question here on how easy it is to use. The answer to that is very. As you saw, you just drag and drop, or you just upload your different input files. The process then, the perspiration, is prior to that in data preparation and then the post-analysis. So we've endeavoured to make a very easy product so that can be used very simply with minimal training. When you do approach your local Maptek office for access, they will probably spend a fair bit of time working with you on how to prepare your data to get the best outcome and to be the most efficient use of the product, rather than going on how to use the product, because it's efficient use, reduce your compute time and get the results quickly.
And we've certainly had that experience, Steve, from our office here in Edinburgh, and I think the other offices globally. When you first introduced this to us, you pretty much just gave it to us and said, "Here you go. No training, no instruction manual. Just work it out." And I don't think anyone had any real troubles. We were pretty much underway within a few hours, and we found it generally pretty easy to use. And I think all of our customers will have that same experience.
No, that's good. Yeah, I did drop you in it, but that was deliberate and that was part of the exercise. Because if it wasn't easy to use, we'd go back to the engineers and get them to change that. So there's quite a lot of questions here. I'm just trying to scan through them all. We've got a couple more minutes, but I've been very pleased with the number of questions and the level of interest that we've got in this session, Gary. So
yes, I certainly hope that we've covered the components of all the questions well. Apologies if we've not, as a lot of the questions come in quite similar, and we just try to summarize them so Steve doesn't answer the same question 5 times.
Yeah, there's the question here about from the various projects, what's the general variance between actuals and the DomainMCF models? Best recorded figure versus the worst. So I guess the best way to look at that, is that when you run, say, 5 models or 10 models, and you look at the spread of data, the spread of the output, you can pick the worst case, you can pick the best case, being that best case of volumes or best case in iron ore grades for the iron ore case, and then you can do the worst case. And I guess the best way to evaluate that is to then put that through an optimization process, whether that be pit optimization or stope for underground, then push that through to a full conceptual design and NPV calculation. Now, Maptek in our portfolio, we can do that very quickly. We have Evolution, which is a genetic algorithm-driven life of mine optimizer, and schedule optimizer. So we can do that very quickly. And we have done that internally. We haven't yet released the results of some of our internal R&D work, but that's certainly something that you look to see in the future, linking up these MCF pipelines, going from raw data right through to scheduled model complete. So got a little bit more work to do on the R&D side there, but that's one way to find out and to quantify what the difference is between the worst case and the best case, and the differences between various models. And as I said before, geological uncertainty is not really well appreciated or not really done in models and resource models around the world, in my experience. I'm not sure about you, Gary, but not many people are doing 4 or 5 different geological interpretations and then putting them through the whole resource process. So DomainMCF can add that capability. And when you're talking about a resource, for me, it's volume, it's grade, and its density. There's 3 components. So people are spending a lot of time on the grade. In fact, a lot of time on the grade. I'm seeing a little bit more done on density over the years, but I've seen previously that was a very poorly researched area of the density, the bulk density. And really, geological uncertainty is that 3rd component, which is now we can speed that process up so people can use that geological uncertainty to ensure that they're getting all 3 components of what needs to go into a resource and understand where the shortfalls or where the gains are. So just looking at the questions, I think we've done a pretty good job covering all those, Gary. So I might just wrap up with the final screen. You can wrap up.
Perfect. Thanks so much for everyone for sending those questions through. It was, I think it was just the right amount of questions. So Hopefully everyone's enjoyed this session today, and you've enjoyed discovering how automated resource modeling will underpin the digital mine planning platform. Now, if you could please take a few moments to fill in a survey, which is going to pop up on your screen anytime now. That would be very much appreciated. So again, apologies if we've missed any questions. Please get in touch with us. You can see Steve and my details on the screen if you'd like to get in touch with us, or please just get in touch with your local Maptek office and someone will be able to get back to you with answers to your questions as soon as possible. The recording of this session will be available in about the next week, and we'll send you a link so you'll be able to share that with your colleagues who've not been able to join this session. And like I said, if you need anyone at Maptek to get in touch with you, please just grab our email addresses there, or just grab your local office. So hopefully you've all managed to get your answers to that little survey popped up and back to us. This will be the end of this broadcast, and thank you very, very much for your time, and please have a safe and enjoyable rest of your day.
Thanks, Gary. Thanks, everyone.